Hello there, friends! Welcome to our Magical Explainer. Today, we're grabbing our imaginary magical magnifying glasses to uncover the cute, hidden secrets of literally everything around us. Have you ever wondered what exactly makes up the things you touch and see every single day? Well, we are going to figure that out together in the most fun way possible. So get nice and cozy, and let's jump right into the amazing world of chemistry. Here's our super fun lesson plan for today. We're looking at Welcome to Matter, tiny building blocks, the moving molecule dance, solids, liquids, and finally, gases. Section 1. Welcome to Magical Matter. So, what is everything? Think about a wooden toy, a cool glass of water, or the invisible air inside a happy little balloon. What do all of these completely different things have in common? They're all made of a very special, magical word, matter. In super simple words, if something takes up room, which scientists call occupying space, and it has just a little bit of weight, which we call mass, we call it matter. You, me, your pet, your school bag, the whole shebang is made of matter. Section 2. Tiny building blocks. Let's zoom way in. Okay, let's take out our magical magnifying glass again. If we look super closely, even closer than our eyes can actually see, we'll discover that matter isn't just one big solid chunk. Nope, it's actually made of tiny, adorable little pieces. Just like cute little Lego blocks you use to build a toy castle, matter is made of basic building blocks called elements. An element is just a pure substance that can't be broken down into anything simpler. And guess what? Scientists have found exactly 118 known elements in our whole universe. Every single thing you can think of is built using just these 118 blocks. Isn't that wild? Now, what if we take just one of those elements and break it down to its tiniest possible piece? If we look at just one tiny, smiling piece of that element, it's called an atom. An atom is literally the very smallest unit of an element. Even though it's incredibly tiny, it's super important because it just loves to take part in chemical reactions. But sometimes atoms don't really like being all by themselves. When atoms hold hands and become best friends, they form something called a molecule. A molecule is the smallest unit of matter that can happily exist all on its own, while still keeping all its normal physical and chemical properties. So while atoms are the single, solo pieces, molecules are happy little groups of atom friends holding hands and floating around together. Okay, time for a super quick check. Let's pause for a second. Try to remember, what do we call the smallest unit of an element? That tiny single building block we just met. Did you guess it? It's the atom. Great job. Now, let's see what these little atom and molecule friends like to do all day. Section 3. The moving molecule dance. You might think the inside of a solid piece of wood or a quiet glass of water is perfectly still, but nope, it's definitely not. The kinetic theory tells us these tiny molecules are never ever still. They absolutely love to move and dance. And there are 3 simple rules to their little dance. First, they're always moving, they have kinetic energy, and they literally never stop. Second, they attract each other like friendly little magnets, which is called the intermolecular force of attraction. And third, they always have little empty spaces between them. How they dance together decides exactly what kind of matter they become. Just look at the 3 different ways our molecule friends arrange themselves here. In the first group, Group A, the molecules are hugging each other so tightly they can barely move. In Group B, they're holding hands a bit more loosely, kind of flowing around. And in Group C, they are flying far, far apart. Let's explore these 3 dancing kingdoms. Section 4. Solids, our tightly packed friends. Let's visit the very first kingdom of matter where the molecules love to hug tightly. Solids. A really great everyday example from your kitchen is a bowl of uncooked rice. Have you ever noticed that when you pour dry rice onto a plate, it piles up into a little mountain? That's because the individual grains are solid. They don't flow perfectly flat like water does. Instead, they form a nice little heap. They hold their shape. So why exactly do solids behave this way? Well, in a solid, those friendly forces of attraction are super strong. Because the molecules are packed so tightly together, solids have a definite shape and a definite volume. If you try to squeeze a wooden block or a small rock, well, you can't. They absolutely cannot be squished or compressed, because there's pretty much no empty space between those molecules for them to move into. Section 5. Liquids, the flowing dancers. Next up, we're visiting our second kingdom, the liquids. Here, the molecule friends hold hands much more loosely. They have a little more space between them, which means they love to glide and slide around each other like graceful dancers. Notice what happens when you pour water into different glasses, maybe a round bowl or a tall, skinny glass. The water magically takes the exact shape of whatever container you put it in. This happens because the molecules in a liquid can smoothly slide right past one another. They aren't totally locked in place like the solids are. Let's quickly summarize our liquids. They have a definite volume, which means 1 cup of milk is always exactly 1 cup of milk, but they have no definite shape. They simply take the shape of their container. Their attraction forces are a bit weaker than in solids, which gives them the space to wiggle and flow. And remember, because of this, liquids always flow downwards from a higher level to a lower level. Section 6. Gases. Flying free forever. Finally, let's float on up into our third kingdom. Gases. This is where the molecules fly completely free with so much happy energy. Now, gas can be a little tricky to think about because we usually can't even see the air around us. So how do we actually know it has mass? Just look at this fun balloon experiment. When 2 empty balloons balance on a stick, nothing happens. But when one balloon is blown up with air, the scale tilts down. This beautifully proves that invisible gases really do have mass and they do take up space, gently pushing our little scale downward. Let's talk about the properties of gases. Gas molecules are very, very far apart. The forces holding them together are almost zero. We call this negligible attraction. Because they have so much energy and so much space, gases have absolutely no definite shape and no definite volume. They will completely fill up any room or container you trap them in. And because there's so much empty space between the molecules, you can really easily squish or compress gases into tiny spaces. Okay, this wonderfully simple chart perfectly summarizes everything we've learned today. Notice how solids have a fixed shape and volume, and they totally refuse to be compressed. Liquids have a fixed volume, but can change their shape to flow around. And gases? Well, they have no fixed shape or volume, they fly everywhere, and they're super easy to squish together. So, what you should definitely take away from today is that matter is everywhere, happily dancing around in different forms. Here's a fun final question to leave you with. Next time you watch a hot cup of tea being made in your kitchen, look super closely. Can you spot the solid tea leaves, the liquid water boiling, and the gaseous steam flying away into the air? Spotting all 3 kingdoms at once means you are absolutely ready for more magical chemistry. Thank you so much for joining me on this wonderful adventure through matter. Keep exploring, keep smiling, and I'll see you next time.